Okay, so last new unit of Chapter 8, last new section, all about factoring perfect square trinomials and difference of squares. We consider those special products. We learned how to multiply using double distribution. So if you look on the whiteboard here, this first one, r minus 3 squared in your notes, r minus 3 squared. Remember, that's the same as r minus 3 times itself, right? But we have a shortcut to multiply that. Does anybody remember the shortcut? By any chance? I'm going to tell you the shortcut. Or remind you the shortcut. So the shortcut is square the first term. Square means multiply by itself, right? R times r is r squared. We're going to multiply the two terms and then double or multiply it by 2. So negative 3 times r times 2 is negative 6r. And then we're going to square the last term. So 3 squared would be positive 9, or negative 3 squared would be positive 9. Remember, a perfect square trinomial always ends in plus. Right? It's always plus the constant. So whether you square a negative or whether you square a positive, it's always a positive. So that makes this a perfect square trinomial. If we use the shortcut to square x plus 4, square the first term, multiply the terms, and then multiply by 2. So 4 times x is 4x times 2, 8x. And then square the last term. So 4 squared is 16. It does not matter if it's got an extra number here. We do the same thing. Square the first term. What's 2n squared? Say it again. 4n squared. Very good. The 2 has to be squared and the n has to be squared. Now, this is 5 times 2n times 2, so that's 10n times 2, which is 20n. So this is a positive, so this one's positive. And then we square the last term, positive 25. So we should be able to recognize when a trinomial is a perfect square trinomial, because then we'll know that we can use the shortcut that we're about to learn to factor. So how do we know that these are perfect square trinomials? Well, we know they're perfect square trinomials because we multiply, there was a square of a binomial, right? But the characteristics that you need to look for if you see a trinomial, perfect square, so that first term is a perfect square. Remember what a perfect square is? It just means it's a product of a number by itself. So r is a perfect square because we said r times r to get r squared. 9 is a perfect square because it has a pair of factors that are identical, 3 times 3, right? So perfect squares have a pair of identical factors. 25 is a perfect square because 5 and 5 are factors. Does that make sense, Akira? Well, everybody take your headphones, AirPods, earbuds off. So the middle term is 2 times the product of the terms. Well, of the square root of the term. Oh no, of the term. things are true, then it's a perfect square trinomial, and we can use the shortcut we're about to learn. So I'm going to factor this first trinomial. Well, first let's check. Is z squared a perfect square? Yes. Is 36 a perfect square? Is 12z, so this is 12, ooh, okay. So this is, I forgot, we gotta go backwards. So, that is what it is in here. So the middle term is 2 times the product of the square roots of the terms, right? So the square root of z is what? I'm sorry, the square root of z squared is what? Z. The square root of 36 is what? 6. So if we multiply that by 2, we have 12z, right? So now we know that this is a perfect square trinomial, because the first and last terms are perfect squares, and the middle term is 2 times the product of the square root. Right here, all of these have the same characteristics. So we can factor this. A perfect square trinomial is always going to be a binomial squared. This part's a little bit tricky. All of the perfect square trinomials are going to have a plus at the end, but they can have a plus or a minus in front of the second term. So our binomial that we're going to factor this to is always going to have this sign. So this is going to be a plus. When we're doing this one, it's going to be a minus, right? So, the square root of z squared goes in the first spot, the square root of 36 goes in the second spot. So here, for this trinomial, 9y squared is a perfect square, 16 is a perfect square. What's the square root of 9y squared, Diane? Sorry? 3y. 3y. And the square root of 16 is what, Ulrich? 4. So 3y times 4 times 2 is 24y. That's our middle term. So we know this is a perfect square trinomial. So now we can use our shortcut. We can give ourselves empty parentheses. We use this operation. And now this is the square root of 9y squared. It goes in the first spot. 4 is the square root of 16. It goes in the second spot. That's all you have to do. If you know it's a perfect square trinomial, take the square root of the first term, put it in the first spot, the square root of the last term, and put it in the last spot. Does that make sense, Keisha? Okay. So the shortcut, we just said square root of the first term plus or minus square root of the last term. Always a binomial squared. Sometimes there is going to be a greatest common factor. And so your trinomial may not look like a perfect square trinomial. Is 2x squared a perfect square? Not, Naya? 2x squared a perfect square? Remember what a perfect square is. A perfect square is a product of two of the same factors. Yeah, so there's not a number we can multiply by itself to get 2, right? 4 is a perfect square because 2 times 2 is 4. 16 is a perfect square because 4 times 4 is 16. The 2 doesn't have any factors that you can multiply by itself to get 2. However, there is a common factor in all of these terms, and that common factor is 2. So we can pull a greatest common factor out first and rewrite it. And now, I suspect that this trinomial is a perfect square trinomial. So now my answer, let's confirm it. What's the square, is x squared a perfect square? Is any variable squared a perfect square? Yes. There's no number with it, that's a perfect square. What's the square root of x squared? X, not 1, x, right? Is 49 a perfect square? What do you think, Jacoy? Is 49 a perfect square? Is there a number you can multiply it by itself to get 49, Jacoy? I can't hear you, Jacoy. What can you multiply by itself to get 49? 6 times 6 is 36. 7 times 7 is 49, so the perfect square, I'm sorry, the square root of 49 is 7. That is a perfect square, the square root is 7. So now x times 7 times 2 equals 14x. So now we know this is a perfect square trinomial. Perfect square, and the middle term is 2 times the product of the square root. So now our shortcut is, we can't forget the 2, but now we give ourselves a binomial square and an empty one. What's going to be this operation, plus or minus? Say it again? Plus, that's right. This plus here tells me it's plus. What's going to go in the first spot, Jaden? Well, x squared times x squared will give me x to the 4th. Remember, I want the square root. So the square root of x squared, so it's just x. Does that make sense, Jaden? What do you want going to go in the second spot, Kendall? Perfect. So this would be your final answer. If there's a greatest common factor that will come out of it, you have to include that in your answer. But you may still be able to use the shortcut to factor it. Does that make sense to you, Tia? Keisha, you have a question for me? There's very little work to show, so no, not really. All right, here we go. That is kind of the whole idea of the assignment, is to use the shortcut, so there's not much work. Now, if you have to pull out a greatest common factor, then you have to show me this work. Does that make sense, Keisha? Okay, so you have to show me that. I know there's at least one problem on your homework. I think it's not a perfect square trinomial. Look, you're going to pull a greatest common factor out, and then I expected it to be a perfect square trinomial, and I don't think it was. So if it's not a perfect square trinomial, you'll use the lesson that we learned in 8.6, okay, or 8.5. All right, so the other special products are difference of squares. These are difference of squares. Perfect square minus a perfect square. All right. We learned that if we saw two identical binomials, except one was subtraction and one was addition, that we could use a shortcut to multiply these. Does anybody remember what the shortcut is? Say it again. Oh no, this is from earlier in the year. Right before Christmas, we learned how to multiply these using the shortcut. What is it, Steve? Multiply r times r and get r squared. Yep. Now what? Not r times 3. Nope. It's always perfect square minus the first term squared minus the second term squared. Alright? Perfect square minus perfect squared. So here, the reason that this works is because the binomials are identical, except one is positive, one is plus, and one is minus. So here, the product of these two identical binomials with different operations, everything's exactly the same except the operation is different. Square the first term is always minus and square the last term. So the products are always perfect squares minus perfect squares. Or sorry, perfect square minus perfect square. If you have a perfect square minus a perfect square, right here, it always factors into two identical binomials except one is addition and one is subtraction. So is x squared a perfect square? Yes. Is 100 a perfect square? Yes. So it's always going to factor into two binomials, so give yourself two binomials. The square root of the first term goes in the first spot. The square root of the last term goes in both second spots. The operation is always 1 minus and 1 plus. It doesn't matter if you put the plus first and the minus, or the minus first and then the plus. The plus, minus. Does that make sense, Brandon? Does that make sense, Lee? Okay. Is n squared minus 64, is that a difference of squares? Is it a perfect square minus a perfect square? Okay, so we should be able to factor it into two binomials. What goes in the first spot, Danielle? N. What goes in the second spot, Lee? 8. 8 times 8 is 64. Very good. Square root of n squared is n, goes in both first spots. Square root of 64 is 8, it goes in both second spots. What are the operations I'm going to put in, Diane? Say it again. On both additions? Perfect. One addition and one subtraction. So it always works that way. If it's a perfect square minus a perfect square, you can always factor it into two binomials that look the same. Yep. Well, now, like the one at the bottom we're about to do, you got to show me a little bit of work. Yeah. So here's the deal. You have to factor out the greatest common factor first, right? Sometimes those can be a perfect. No, I guess that wasn't you. You have to factor out the greatest common factor first. So let's look at this one. What's the greatest common factor here? 3. So we're going to rewrite this as 3 times n squared, because 3 times n squared gives me n squared, minus 3 times 1 gives me 3. Is this a difference in squares? Is n squared minus 1 a difference of squares? Is the first term a perfect square? Is the last term a perfect square? Is 1 a perfect square? Yeah, because 1 times 1 is 1, right? Perfect. So now, we are going to include our greatest common factor, give us two binomials. We know one's always going to be addition and one's always going to be subtraction, but I put them in different order just to remind you that the order doesn't matter for the addition and subtraction. What's going to go in the first spot, Gladys? And what's going to go in the second spot, Brooklyn? No. What times what gives me 1? 1. Square root of 1 is 1. So that is your final answer. On the front page of your homework, you have some squares. You do those just like you do the top part of the page. Okay? The size dimensions from the area size times size, right? So it's just like the top of the page. On the back of the page, there are some other you to pull out a greatest common factor first, and then you have to figure out if it's a perfect square trinomial. After you do that, I don't think that, I think there's one on the back page, at least that I know of. I don't think that 42 is going to be a perfect square trinomial when you pull the greatest common factor out of it. A 3 will come out of all of them. And I don't think that, so you're going to have to use the way we factored in yesterday's assignment for that one. Okay? But double check me. What time do we get out? Oh, thank you. 10:44. Yes. Hurry up. Yeah, 200 minutes. Well, good thing will be it, the majority of them are, and I ask them every day, and remind them that they could do them for when time late. Is there one more? I'm about to give you that one, and I probably know why I do it, and that one too, but, they making their decisions, and I can't do anything about that. I can only encourage them, I give them extra time.